Hello everyone. In this video we are going to learn how to find number of shortest paths in a grid from one corner to the opposite corner. Now the grid can be a perfect grid or it can be a partial grid. The given example is a partial grid. So over here the question is in how many different ways we can travel from point A to point B along the grid, not along the diagonals, along the grid by using shortest paths. How to solve this, but before that we need to learn the concept of perfect grid. So let's have a look at it. This is the example of perfect grid now. So over here, in how many different ways we can travel from point A to point B along the grid by using shortest path. First of all, let's understand what do we mean by shortest path. Once we go up we cannot come down, and once we go to the right we cannot come to the left. So for example, over here this path is not a shortest path, because once we go up we cannot come down. That is why this path is not a shortest path. So how to find number of shortest path, everyone? Let's have a look at it. Before that, let's understand this grid. This is a complete grid, perfect grid of dimension 5 by 4. All vertical lines are parallel to each other, all horizontal lines are parallel to each other, each interior angle formed is 90 degree. The length of line segments is equal, the length of each line segment is equal, like 1, 1, 1 and 1. So now what do we mean by shortest path over here? Let's have a look at it. This is called as shortest path. Similarly, this is also called as shortest path. So let's have a look at it, everyone. So to travel from point A to point B, we need to travel 5 horizontal segments and 4 vertical segments. So now this red path is 2 horizontal segments, then 2 vertical segments, then 2 horizontal segments, then 2 vertical segments, and then 1 horizontal segment. Now the green path is 3 vertical segments, 3 horizontal segments, 1 vertical segment, and then 2 horizontal segments. Now these two paths, are we going to consider these two paths as different paths or same path, everyone? Yes, they are considered as different paths, everyone, because the arrangements is different. So to travel from point A to point B, we need to travel 5 horizontal line segments and 4 vertical line segments. Every arrangement, let's consider this as a 9-letter word. Every arrangement of this word will generate a new path. For example, this is one of the arrangement of this 9-letter word. This is one of the arrangement of this 9-letter word, such that every arrangement will generate a different path. So the number of arrangements is going to be how much? Number of arrangements is going to be same as the number of shortest paths. So in how many ways we can arrange this 9-letter word? Total 9 alphabets, so 9 factorial. 5 H are identical divided by 5 factorial. 4 V's are identical divided by 4 factorial. So these many number of paths, these many shortest number of paths are available along the grid to travel from point A to point B. If you solve this, this will be how much? 9 factorial is 9 into 8, 7, 6 into 5 factorial, divided by 5 factorial into 4 into 3 into 2 into 1. So if we solve this further, what we will get? 4 2s are 8 and it gets cancelled out. 3 3s are into 7 into 6. So this multiplication is 21 into 6, that is equal to 126. There are 126 different shortest paths are available to travel from point A to point B along the grid. Over here there is a direct formula as well. If the grid is of dimension m by n, then the number of shortest paths from one corner to opposite corner is equal to m plus n factorial divided by m factorial into n factorial. This is the formula to find the number of shortest path along the grid from one corner to the opposite corner. This is first method. There is a second method as well, that is a manual counting. Let's have a look at it. So over here To travel from point A to point B, let's start from point A. In how many ways a person can reach at this point? There is only one way. A person can reach at this point is only one way, by using shortest path. A person can reach at this point, there is only one way. There is only one shortest point to reach here. There is only one shortest point to reach here. Same thing is going to happen over here as well, everyone. So to reach at each of these points from point A, there is going to be only one shortest path. So to reach at this point, how many different paths a person can have? 1 plus 1, 2. To reach at this point, this 2 plus 1, 3. To reach at this point, there are going to be 3 plus 1, 4 ways. To reach at this point, there are 5 ways. To reach at this point, 5 plus 1, 6 ways. After that, to reach at this point, 2 plus 1, 3. Then now 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 6, 21. Now to reach at this point, 1 plus 3, 4. 4 plus 6, 10. 10 plus 10, 20. 20 plus 15, 35. 35 plus 21, 56. Now to reach at this point, 1 plus 4 is 5, 5 plus 10 is 15, 15 plus 20 is 35, plus 35 is 70, 70 and 56 is 126. So to travel from point A to point B, there are going to be 126 shortest paths along this grid. So whenever the given grid is not a perfect grid, then we need to do that by manual counting like this. For example, let's have a look at this example. In how many ways we can travel from point A to point B by using shortest possible paths? So let's have a look at it. From point A to this point, a person can travel in only way. This point, a person can travel in only one way. Similarly to this point and this point, there is only one shortest way to travel from point A. To this point also there is only one shortest way. So now to reach at this point, 1 plus 1, 2. Over here 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. Now to reach at this point from point A, how many different ways are there? How many different shortest ways are there? So over here, to reach at this point, it is compulsory to go via this point. So there are two ways to reach at this point. So there are also two ways to reach at this point. Now 2 plus 3 is 5, plus 4 is 9, plus 5 is 14, plus 6 is 20. To reach at this point, we need to travel by using this point. So to reach at this point, there are 5 possible ways. So over here also 5 possible ways are there. After that, 5 plus 9, 14 plus 14, 28 plus 20, 48. Now to reach at this point, the only possible way is via this point. There are 14 ways to reach over here. So there are 14 ways to reach here as well. 14 plus 28 is 42. 42 plus 48 is 90. To reach at this point, we need to travel via this point only compulsorily. This point we can reach in 42 different ways. So this point also we can reach in 42 different ways. Now 42 plus 90 is equal to 132. So in how many ways we can travel from point A to point B? There are 132 possible shortest paths are available. This is how we can deal with the grid, if it is perfect grid or if it is a partial grid.